Question 1. In the context of energy auditing for large commercial buildings, Izzy Patel observes that a variable air volume valve system consistently operates at full fan speed regardless of zone demands. Her audit reveals that the valve boxes are all receiving maximum airflow despite varying load conditions across zones. What is the most appropriate explanation for this behavior? A fault in the economizer logic is overriding normal valve operations. B. The valve dampers are fully closed, causing static pressure to rise. C. The static pressure sensor is incorrectly located, resulting in poor fan modulation. D. The ductwork sizing is too large, causing fan inefficiencies. Answer. Correct answer. C. Explanation. A common issue in poorly commissioned systems is the misplacement of static pressure sensors, often too close to the fan or in a zone not representative of worst-case airflow. This causes the fan to ramp up unnecessarily, defeating the energy-saving purpose of valve systems. ASHRAE Guideline 36 emphasizes the importance of placing sensors in a location that reflects the most critical zone. Answers A and B are plausible but less likely unless other control faults exist. Oversized ducts D may reduce fan energy but do not force maximum speed. This reflects an improper control response to pressure readings. Question 2. As demonstrated by recent audits of hospital HVACR systems, high energy use during unoccupied hours is frequently traced back to improper setback strategies. In reviewing the automation logs of a hospital's AHAS, Ista Rosario notices that air handlers continue to run at design airflow during nights and weekends. Which control modification would provide the greatest energy savings without compromising patient safety or indoor quality? A. Replace the VFDS with constant speed motors to avoid control complexity. B. Implement scheduled shutdown of AHAS regardless of occupancy. C. Integrate occupancy-based demand control, ventilation, and reset logic. D. Increase airflow during unoccupied hours to maintain pressurization. Answer. Correct answer. C. Explanation. ASHRAE 90.1 and ASHRAE 170 allow for ventilation turndown strategies when patient spaces are unoccupied as long as air quality and pressure relationships are maintained. Using occupancy sensors with demand control, ventilation, and static pressure reset logic can reduce energy usage significantly. Options A and D either waste energy or compromise the intent of efficiency. Option B risks violating air change or infection control standards. Automation fine-tuning aligned with facility usage offers optimal performance and safety. Question 3. The implications of failing to insulate HVACR components were evident during an audit performed by Is Collins on a chilled water system in a high-rise office tower. She noted condensation issues and heat gain across long pipe runs even though the chiller plant was operating efficiently. Which component is most likely contributing to this inefficiency and IAC concern? A. Improperly sized expansion valve. B. Uninsulated chilled water supply and return lines. C. Fan speed mismatches causing turbulent airflow. D. Short cycling of the primary chiller. Answer. Correct answer. B. Explanation. Uninsulated or poorly insulated chilled water piping results in latent heat gain, leading to condensation, elevated humidity, and increased chiller load. This not only wastes energy but can cause mold growth or damage finishes, violating ASHRAE 55 and 62.1 IAC standards, while A, C, and D could contribute to performance issues. They do not directly correlate with condensation. Heat gain across pipe runs. Correct pipe insulation per ASHRAE 90.1 is critical. Question 4. From the perspective of psychrometric analysis, what occurs when air passes over a cooling coil and reaches dew point, continuing to be cooled further? A. Sensible heat is removed only and dry bulb temperature drops. B. The air undergoes sensible and latent heat removal, lowering both dry bulb and humidity ratio. C. Only latent heat is removed, resulting in higher air density. D. The process follows a constant wet bulb line with no change in enthalpy. Answer. Correct answer. B. Explanation. As moist air cools below its dew point, water vapor condenses out latent heat loss, while the air also continues to cool. Sensible heat loss. This dual process reduces both the dry bulb temperature and the humidity ratio. On the psychrometric chart, this appears as A diagonal line descending leftward. ASHRAE Fundamentals provides this principle for coil performance and latent load calculations. A and C oversimplify the process. D is incorrect. Enthalpy clearly drops as energy is removed. Question 5. Taking into account the operating behavior of dual-duct air systems, Mr. Watanabe observes that simultaneous heating and cooling is occurring at several terminal units even during mild outdoor conditions. Which of the following audit actions would best improve the system efficiency? A. Reduce the supply fan speed during part load hours. B. Disable the heating coil circuit entirely. C. Tune the control logic to avoid mixing hot and cold air simultaneously. D. Increase minimum airflow set points for valves. Answer. Correct answer. C. Explanation. Simultaneous heating and cooling, referred to as reheat waste, is a sign of poor control logic in dual duct systems. Tuning the terminal unit controls to prioritize economy mode or sequence temperature control can eliminate this energy waste, and ASHRAE 90.1 discourages reheat when not absolutely necessary. Option A may help marginally but doesn't address the root cause. Option B is too aggressive and can violate thermal comfort standards. Option D increases fan and reheat energy unnecessarily. Question 6. Given the circumstances where refrigerant R400 TINA is being retrofitted out of, a building due to environmental regulations, Istedalian is tasked with selecting a suitable alternative that aligns with low global warming potential goals. Which of the following refrigerants provides a more climate-responsible alternative with significantly reduced while maintaining performance similar to R400 TINA? A. R134, B. R290 propane, C. R32, D. R407. Answer. Correct answer. C. Explanation. R32 is a hydrofluorolefin with roughly one-third the DDB of R400 TINA and similar thermodynamic characteristics. It's increasingly used in new systems and meets UF gas and EPA SNAP criteria. While R290 it poses flammability concerns and is not direct substitute. R134 and R407 still have relatively high DDB and are being phased down globally. EPA Rule 21 under Section 608 in the International Kigali Amendment targets promote transit to LDU alternatives. Question 7. Under the assumption that system performance should be verified post-installation, Bell is reviewing the measurement and verification in V-Plan after a major retrofit involving VFDS and air handlers. What is the most appropriate baseline selection method according to Option B? A. Use engineering estimates for savings without measurement. B. Use spot measurements of utility data only. C. Conduct continuous measurements on key parameters pre and post-installation. D. Apply a deemed savings value from regional programs. Answer. Correct answer. C. Explanation. Option B of the ITM protocol emphasizes retrofit isolation with all parameter measurement. Continuous data on power draw and system output before and after the retrofit allows for accurate savings verification. Engineering estimates A align with option A, not B. Deemed savings D fall under option C or D. Accurate MV is critical for utility rebate validation and ongoing performance assurance per ITM Volume I and ASHRAE Guideline 14. Question 8. Throughout the course of a facility audit, ISTA Suarez identifies multiple rooftop units are thus lacking economizer functionality, even though the climate is ideal for free cooling during several months. Which strategy should be prioritized to capture cost-effective energy savings? A. Replace all RTUS with high C units regardless of age. B. Install dry coolers for supplemental free cooling. C. Retrofit economizer controls with outside air temperature sensors. D. Increase supply airflow to reduce indoor temperatures. Answer. Correct answer. C. Explanation. Economizers allow systems to utilize outdoor air for free cooling, reducing mechanical cooling loads, installing economizer controls where conditions support it. E.g. mild climate is a proven econ with short payback supported by ASHRAE 90.1 and DOE retrofit guidance. Option A is expensive and may not be justified if units are not at end of life. B is viable for chilled water systems, not ARTUS. D increases fan energy without significantly improving efficiency. Question 9. From multiple perspectives, how does poor building envelope insulation affect HVACR system efficiency and load calculation accuracy? A. It has minimal effect due to internal loads dominating. B. It increases infiltration but has no effect on cooling loads. C. It causes fluctuating heating cooling loads and oversized system selection. D. It improves natural ventilation and reduces HVAC energy. Answer. Correct answer. C. Explanation. Poor insulation and sealing result in unpredictable heat gain losses and infiltration, which complicates accurate load calculations. This often leads to oversized equipment, reducing efficiency and comfort. ASHRAE load calculation manual and a CAM manual J emphasize tight envelopes for reliable sizing. A and B ignore the fundamental thermal load balance. D misrepresents uncontrolled airflow as a benefit. ASHRAE 62.1 regulates fresh air intentionally, not via leakage. Question 10. Examining the consequences of inadequate filter maintenance is NASA inspects a multi-zone air handling system where dirty MERV 13 filters have been in place for 18 months. Occupants report discomfort and rising utility costs. What is the most likely combined impact of this oversight? A. Reduced airflow, increased fan energy use, and decreased IAC. B. Lower pressure drop, extended equipment life. C. Improved filtration and better zone control. D. Unaffected system performance due to redundancy in filter banks. Answer. Correct answer. A. Explanation. Clogged filters raise pressure drop, forcing fans to work harder, increasing energy consumption and reducing airflow, which compromises IAC and comfort. ASHRAE 180 recommends scheduled inspection and replacement to preserve system health and compliance. Options B and C contradict physical principles. D is a misconception. Redundant filters still require maintenance. This is textbook example of neglected preventive maintenance reducing operational performance. Question 11. While examining a recently installed building automation system, Bassin, a university campus, Mr. Lambert identifies that although the system has advanced scheduling and control algorithms, it is consistently overriding manual set points made by facilities staff. The staff complains that space conditions do not match occupancy needs, especially during irregular events. Which improvement should Mr. Lambert recommend to balance energy savings and control? They lock all manual overrides permanently to maintain algorithmic efficiency. B. Disable all scheduling and return to manual operation only. C. Implement zone-level override permissions with time limits and logging. D. Install coast sensors to eliminate the need for manual control. Answer. Correct answer. C. Explanation. ASHRAE Guideline 36 supports integration of override features within BAS platforms, allowing temporary user control while maintaining central efficiency. Time-limited overrides with automatic reversion and audit logs maintain accountability. Disabling automation. B is regressive. Option A ignores occupant comfort. Co-sensors. D help with ventilation control but don't address scheduling conflicts. Customizable control logic aligned with real-world usage ensures both performance and satisfaction. Question 12. Among the various causes of erratic compressor cycling in a multi-zone split system, Mr. Chen observes rapid cycling despite normal load conditions. On inspection, he finds the thermostats are placed near supply diffusers in multiple zones. What is the most likely effect of this thermostat placement? A. Improved comfort due to faster system response. B. Frequent short cycling and reduced compressor life. C. Balanced temperature distribution across the space. D. Enhanced dehumidification through extended runtime. Answer. Correct answer. B. Explanation. Thermostats near supply outlets are affected by cooler supply air, causing premature shutdowns and startup cycles. This leads to equipment wear, inconsistent humidity control, and reduced efficiency. ASHRAE 55 and manufacturer guidelines recommend placing thermostats in representative return air or occupied locations. A and C contradict the control intent. D would require longer run times, not short cycling. Proper sensor placement is crucial for system stability and longevity. Question 13. The relationship between fan power and airflow is evaluated by IS freighters during. At Auditor data center, the site operates multiple fans at constant speed, with static pressure maintained by manual dampers. What energy conservation measure should she propose to optimize fan energy usage? A. Replace dampers with high efficiency models. B. Remove dampers entirely and let fans run at full speed. C. Install VVFDS and implement static pressure reset based on zone demand. D. Install larger fans to reduce RPM and noise. Answer. Correct answer. C. Explanation. ASHRAE 90.1 and the Advanced Energy Design Guide recommend pairing VVFDS with static pressure reset to optimize airflow. This ECM allows fans to slow down under reduced demand, saving energy significantly due to the cube law, power equals PEED. Damper replacement A or removal B does not address inefficiencies. Larger fans D may reduce noise but don't dynamically adjust airflow demand. PFD control is proven strategy for HVAC optimization. Question 14. To better understand energy distribution across a mixed-use building, HVACR installs submeters on multiple HVAC circuits. She finds the largest unexpected energy load is associated with the elevator machine room's constant cooling unit, even in winter. What should she recommend to address this inefficiency? A. Disconnect the unit seasonally to save energy. B. Replace the system with free cooling using outside air and controls. C. Add more internal insulation to reduce internal heat gains. D. Install occupancy sensors to cycle the unit with use. Answer. Correct answer. B. Explanation. Elevator rooms often require cooling year-round due to heat from motor systems, but outdoor air economizers or heat exchangers can offer free cooling, especially in winter. ASHRAE 90.1 encourages this via the economizer exemption clause. Option A risks overheating critical systems. C won't reduce equipment heat load. Occupancy sensors D are ineffective for systems with constant thermal loads. Utilizing climate-appropriate ventilation reduces unnecessary mechanical cooling. Question 15. From a historical standpoint, Mr. Thomas is reviewing past energy audit data for a shopping mall and sees repeated recommendations to upgrade to ECM motors, but the facility has never implemented them. What justification should he provide in his audit report to finally prioritize this measure? A. ECM motors have better warranty coverage. B. ECMs offer variable speed without requiring VVFDS, yielding higher efficiency. C. ECMs can eliminate duct leakage problems. D. ECMs reduce refrigerant charge requirements. Answer. Correct answer. B. Explanation. Electronically commutated motors ECMs integrate speed control within the motor itself, offering high efficiency without needing separate VVFDS. This is especially valuable in variable load systems like fan coils or RTUS. Though an RE data show 3060% savings over PSC motors, A is not the primary concern. C is unrelated. ECMs affect fan energy, not duct sealing. D also doesn't apply, as motors don't impact refrigerant charge. ECM retrofits are low-cost, high-return ECMs. Question 16. By evaluating building pressurization logs, Mr. Armstrong discovers that a pharmaceutical lab facility experiences frequent pressure reversals between clean and general zones. The air balancing contractor reports no damper failure. What factors should be investigated next to resolve the issue? A. The duct insulation thickness. B. Supply fan discharge temperature. C. Exhaust fan speed modulation accuracy. D. Number of return grills in each zone. Answer. Correct answer. C. Explanation. Maintaining differential pressure is crucial in cleanroom and lab environments. If exhaust fans are not modulating in sync with supply airflow, especially under variable load conditions, reversal can occur. ASHRAE 170 and ANSY's guidelines emphasize precise control of airflow direction. A, B, and D may affect comfort or thermal load, but not directly cause pressurization issues. Exhaust fan control calibration should be a top diagnostic focus. Question 17. In terms of indoor air quality in schools, Mr. Ahmed observes high CO levels in several classrooms even when HVAC systems are operational. Airflow readings at diffusers are within expected range, yet ventilation effectiveness seems low. Which issue is the most probable cause? A. Filter 2. restrictive, limiting total airflow. B. Return air is bypassing outdoor air dampers. C. Outdoor air intake dampers are stuck, closed, or undercalibrated. D. Classrooms are overventilated due to oversized systems. Answer. Correct answer. C. Explanation. ASHRAE 62.1 requires minimum outdoor airflow based on occupancy. If intake dampers are closed or miscalibrated, CO will accumulate even if total airflow appears adequate. The system may just be recirculating indoor air. A. It may restrict air but wouldn't explain normal diffuser readings. B. Is mischaracterized. Return bypassing outdoor air doesn't explain lack of dilution. D. Contradicts the observed high CO levels. Checking outdoor air damper operation is essential. Question 18. Through the lens of ethical auditing practice, Rivera discovers that the facility manager has disabled demand limiters during peak rate periods to maintain full comfort levels. However, this increases peak charges and skews the audit results. What is the most professional action she should take? A. Ignore the change and proceed with average data trends. B. Flag the action in her report and recommend a revised control strategy. C. Remove peak rate data to simplify reporting. D. Disable demand limiters again for consistency during audits. Answer. Correct answer. B. Explanation. ASHRAE's Code of Ethics and ISO 50002 require auditors to report conditions honestly and objectively. If facility control strategies inflate consumption, it must be documented transparently. Recommending demand limiting strategies and peak shaving aligns with energy management best practices. Options A, C, and D violate audit integrity or perpetuate poor energy practices. Ethical reporting builds trust and drives systemic improvement. Question 19. In response to an increase in energy bills, Anders investigates a hotel's heat pump water heating system and finds the system operating even when storage tanks are already at set point. The system lacks staging or cutoff logic. What should be the top ECM recommendation? A. Install timer to shut off the system daily. B. Add temperature sensors and logic for low base staging. C. Replace the heat pumps with gas boilers. D. Lower the thermostat setting permanently. Answer. Correct answer. B. Explanation. Heat pump water heaters are efficient, but continuous operation wastes energy. Load-based staging using temperature sensors and control logic prevents unnecessary cycling per DOE commercial water heating standards. A. Risks underheating during occupancy. C. Contradicts energy and decarbonization goals. D. Reduces hot water comfort and could violate health codes. Smart control logic preserves efficiency and performance. Question 20. The effectiveness of IX strategies in retrofitted office buildings is often influenced by both mechanical and behavioral factors. Novik evaluates a building that recently added high MERV filtration but still reports high PM.5 levels indoors. What is the most likely root cause? A. The filters were not installed according to manufacturer instructions. B. The HVAC system was overpressurized by excess ventilation. C. The building envelope was sealed too tightly. D. Employees are generating too much dust through equipment. Answer. Correct answer. A. Explanation. High-efficiency filters are only effective if installed correctly with no bypass leakage or gaps in frames. ASHRAE 52.2 and 62.1 stress the importance of proper filter housing, gasketing, and installation. Overpressurization. B. May affect comfort but not PM.5 directly. C. May improve IAC by preventing infiltration. D. Is rarely significant enough without heavy industrial activity. Proper commissioning of filtration upgrades ensures their intended effectiveness. Question 21. As illustrated by a recent inspection at a data-intensive office building, Jennings noted that the chilled water system operated year-round at full capacity even during mild winter conditions. Occupants still complained of humidity and uneven cooling. Logs revealed poor modulation of chilled water valves. What should Jennings recommend as the most effective corrective action? A. Replace the chillers with high-efficiency magnetic bearing units. B. Integrate chilled water reset logic based on building load and outdoor temperature. C. Increase supply airflow to improve thermal balance. D. Clean cooling coils to improve heat transfer. Answer. Correct answer. B. Explanation. Chilled water reset control adjusts supply temperature based on building load or outdoor conditions, reducing unnecessary chiller operation. ASHRAE 90.1 endorses reset strategies to reduce energy use. Option A is costly and premature. C may help minor comfort issues but not address overcooling or efficiency. D is routine but irrelevant if the system already meets capacity. Control optimization delivers high returns with minimal investment. Question 22. Based on the information collected during a lighting and HVACR audit, Duart notes that occupancy sensors are installed only in lighting circuits and not integrated with HVAC zones. Rooms are conditioned even when unoccupied. What should be her primary energy conservation recommendation? A. Upgrade lighting to LED fixtures to reduce internal heat. B. Add zoning and occupancy-based controls to HVAC systems. C. Increase ventilation rates to dilute conditioned air. D. Relocate thermostats closer to lighting sensors. Answer. Correct answer. B. Explanation. HVAC zone level occupancy controls, such as setback or equipment cycling based on room presence, yield significant savings, especially in intermittent use spaces. ASHRAE 90.1 and ISO 50001 support this integration. A. Saves lighting energy but doesn't solve conditioning waste. C. Would raise energy usage. D. Might improve temperature sensing but doesn't address runtime efficiency. Cross-system integration enhances whole building performance. Question 23. When analyzing a manufacturing facility's utility bills, Mr. O'Neill notes demand spikes that align with startup of large HVAC compressors and chilled water pumps. Load profiles show brief but intense peaks. Which demand-side management strategy best addresses this issue? A. Decrease chiller setpoint temperatures to lower cycling frequency. B. Install thermal energy storage to shift compressor operation off-peak. C. Add economizers to all rooftop units. D. Increase chilled water loop pressure to speed recovery. Answer. Correct answer. B. Explanation. Thermal energy storage decouples generation from consumption, allowing chilled water or ice to be produced during off-peak hours and used later, flattening demand spikes. DOE and utility demand response programs endorse this for managing peak loads. A. May reduce frequency but not demand magnitude. C. Reduces total energy, not peak. D. Increases pump energy without addressing the core problem. Peak shaving through storage is mature and effective solution. Question 24. To illustrate this point, Mr. Weber evaluates a logistics facility's heating system and observes the gas-fired unit heaters cycle frequently during door operations. The building has high infiltration from vehicle bays. Which ECM should be prioritized for both energy savings and improved comfort? A. Add vestibules and air curtains at major door openings. B. Install electric resistance heaters at all dock points. C. Increase indoor temperature set points to compensate for losses. D. Install programmable thermostats with deadband control. Answer. Correct answer. A. Explanation. Air curtains and vestibules limit uncontrolled air exchange, significantly reducing heat loss due to infiltration, especially in industrial settings. ASHRAE Handbook. HVAC applications support such envelope modifications as first-tier ECMs. B. Would increase energy use. C. Is inefficient and may increase complaints. D. Optimizes controls but doesn't solve air leakage. Proper physical barriers reduce load while improving conditions. Question 25. Examining the consequences of improper refrigerant management, ISHAR audits a chain retail store and finds technicians using R22 in newer equipment labeled for R407. The systems show reduced capacity and high head pressures. Which risk does this situation pose most critically? A. Energy code violation for using non-condensable refrigerants. B. Equipment overheating due to oil incompatibility and improper phase change. C. Minor performance drop that is within tolerance. D. Only increased humidity due to capacity loss. Answer. Correct answer. B. Explanation. Mixing or mischarging refrigerants can result in improper lubricant transport and incompatible pressure-temperature relationships which strain or damage components. EPA Section 608 prohibits improper use and mandates recovery and verification. A. Misrepresents R22 as non-condensable. C. Underestimates severity. D. May occur but isn't the core risk. Proper refrigerant usage and verification are critical for safety, efficiency, and compliance. Question 26. The development of ERF systems has enabled more dynamic load matching in buildings with variable occupancy patterns. Is Kim audits an office retrofitted with ERF but notes high energy bills persist? What is a likely oversight in ERF implementation that she should investigate? A. Incorrect refrigerant line lengths. B. Lack of centralized control, integration, and zoning logic. C. Low SEER rating of ERF outdoor unit. D. Use of ECM motors in indoor units. Answer. Correct answer. B. Explanation. ERF systems achieve efficiency through zoning, demand-based load sharing, and centralized logic. Without proper integration, simultaneous heating, cooling, or uncoordinated operation can reduce savings. ASHRAE 15 and ERS-specific design guide stress commissioning of zoning logic. A. Affects refrigerant charge but not operational sequencing. C. Is rare. ERF systems generally have high SEER. D. Is beneficial, not problematic. Centralized control is the backbone of ERF efficiency. Question 27. In contrast to a constant volume system, a properly configured VAV system should deliver air based on real-time thermal demand. Mr. Davies observes several VAV terminals in a school constantly requesting maximum flow. What is the most likely root cause? A. Static pressure sensor set too high. B. AHU is oversized for the application. C. Zone temperature sensors are malfunctioning or miscalibrated. D. Ducts are undersized, limiting airflow. Answer. Correct answer. C. Explanation. If temperature sensors report inaccurate readings, e.g. too high, VAP boxes will open to full flow in a false attempt to reach set point. ASHRAE 111 outlines test and balance protocols, including sensor validation. A. Affects fan speed, not zone damper position. B. May reduce efficiency but doesn't explain box behavior. D. Restricts flow but wouldn't cause full demand unless sensors misread conditions. Sensor accuracy ensures true load-based modulation. Question 20. The core principles of energy-efficient HVAC auditing include accurate load profiling. Mr. Zaman finds the audit model significantly underestimates winter heating demand in a new high-rise building. What modeling assumption is most likely flawed? A. Overestimated internal gains from lighting and equipment. B. Incorrect duct friction factors. C. Excessive cooling ventilation rates. D. Underestimated economizer performance. Answer. Correct answer. A. Explanation. Internal gains from lighting. People and equipment are subtracted from heating loads in simulations. If these gains are overestimated, models will show less heating demand than reality. ASHRAE Handbook. Fundamentals warns of this common pitfall. B. Affects fan sizing. C. Relates to cooling loads. D. Helps during shoulder seasons but not winter. Load modeling must reflect realistic occupancy and equipment schedules. Question 29. Focusing specifically on documentation practices is Tran Review's energy audit report submitted by a third party. She notices vague language like recommend upgrading equipment for efficiency without calculations or cost impact. What guidelines should she follow to correct this reporting flaw? A. ASHRAE 90.1 performance rating method. B. ISO 50002 standard on energy audit reporting. C. ANSI ASHRAE standard 189.1 for high performance buildings. D. DOE commercial equipment standards. Answer. Correct answer. B. Explanation. ISO 50002 specifies structured reporting, including baseline data, ECM quantification, cost-benefit analysis, and MV plans. Reports lacking this detail are insufficient for implementation or funding decisions. A. Defines energy modeling. C. Addresses sustainable design, not audit format. D. Lists equipment specs but not documentation standards. Clear, comprehensive reports are essential for stakeholder buy-in and project execution. Question 30. The validity of equipment sizing depends on multiple factors. Mr. ISAC audits a hotel's replacement rooftop unit, which frequently short cycle. Load calculation documentation shows sizing was based on nameplate occupancy, not actual use patterns. What corrections should he recommend for future equipment selection? A. Use a cab manual. D. For duct layout. B. Base loads on actual usage profiles and occupancy schedules. C. Add thermal mass to reduce peak loads. D. Increase unit capacity to ensure performance. Answer. Correct answer. B. Explanation. Real-world usage often deviates from theoretical occupancy or 100% load assumptions. ASHRAE and ACA recommend basing loads on actual usage, climate data, and building characteristics. Oversized unit short cycle reduce dehumidification and increase energy costs. A is about duct design. C may help but is indirect. D worsens the problem. Accurate usage-driven load calcs ensure right-sized, efficient systems.